you have met logs already, some of you not so much. The reason that we deal with logs and exponents together, or at the same time or a similar time, is because they are related to each other. They are inverse functions of each other. So you know how we have squares and square roots. They undo each other. Logs and exponents are a similar situation. They're inverse functions of each other. If we were given a graph, an exponential graph like this, then a log graph would be at the inverse of it. It would be a reflection of that graph in the line y equals x. Now, you would have met inverse functions previously. Do you remember those? No, inverse functions are x to the minus 1. Do you remember that's where you switch the x and y values? Okay, so we switch x and y values, which is what makes them always reflections in the line y equals x. Okay, we know that exponential graphs go through the value 0, 1. Log graphs would therefore go through the value 1, 0, because our x and our y values are switched. It's to give you a little bit of an intro. We will come back probably to this page later on, but I just want to explain why we're looking at them at a similar time. So, logarithms in base 10. You get given this thing here in your formula booklets, in your information booklet. So you get given that. You don't need to learn this. But what it does, it enables us to rewrite our exponential statement to be an equivalent log statement. Okay. Now, I don't like to harp on what the letters actually are. I try and connect the positions that they are. So, what do we know that this number here is called? What's that called? That's the base. Yes. Well, funnily enough, for a log statement, they will all have a base. And that value, that letter, is going to be the same one. Now, it's written in a different position, as you can see, but our log base is always written subscript next to the word log. I then always just remember that my power is separated, and that's going to come on the other side, and whatever it was equal to is now attached to my log statement. Okay? You just need, and as I say, you don't need to remember this, but the more you do it, and the less you have to look at this formula, the easier it becomes. Okay? Now, why am I going on about that? Well, sometimes you will see something that just looks like this, just says log 100. And in order to establish what these values are, we need to know what the base is. So if there is no number written there, we know that it is secretly 10. Okay, so if there is no base written, we know that it must be log base 10. So, we may be asked to find the value of something. So if I'm asked to find the value of log of 10,000, okay, we may not have our calculators with us, but if I call this now x, I know that secretly I have a base of 10. Yes? So using this conversion, I want to go from a log statement to a power statement. What would I do? So try and remember, so our base is the A, so our base is 10, so the power of x equals 10,000. Yes? Now we need to know what that would be. Now, for a base of 10, that should be super easy. It's 4. Why is it 4 to me? There are 4 zeros. Oh, that's it. Yeah? Press the ends. Similar situation. We've got 10 to the power y equals 0. Oh gosh. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, this isn't written as a nicer way, is it? Okay. How else could we write this value here?
10 to the power of
10 to the power of 1, 2, 3, 4, 5, 6, 7, 8. Is it 10 to the power of? No.
What we doing?
What we doing? Okay, so we're going to say 1, 2, 3, 4, 5, 6, 7. So that's to the negative 7. So therefore y is negative 7. Okay, just the S. Now we've got different base. Okay, so the same rules apply. The same, we would use this formula here. Well, this is this formula a lot to interchange them. Okay, so if I've got log base 2 of 1/4 equals negative 2, that could be written as 2 to the power of negative 2 equals 1/4. Okay. We know that's true because we know that when we have negative powers, it becomes 1 over. So this is not asking you to evaluate anything or find anything, it's just asking us to write an exponential equation. So that would be this, okay, because we've no longer got a log statement, we're just exponents. No, you shouldn't have to, no. I mean, obviously if there was something else going on up there, you would, but no. These are often on the non-calc because they don't want you to just chuck stuff in the calculator. So this one they want us to go the other way. So they've given it to us in power form and they want us to write log statements. So we would write log. What base do we have? 2. What goes with the, 64 equals 6. Okay? So this process here is just getting you practicing going from one format to the other. And then we need to find log base 9 of 3. So again, if I'm trying to find something, I'm going to probably say, right, I'm going to call it x, because that's what I need to actually establish. So this could well be on the non-calc, because if you had your calculator, you could just literally type log base 9 of 3 and it would tell you what the answer was. But by having it on the non-calculator, you have to understand the rules of logs. So writing my power statement from this, what would I write? 9. Okay. So we have to now say to ourselves, what power do I have to give 9 to get to a 3? Not negative. A half. Nice. We remember that now?
Oh, yeah.
Because 9 to the power 1/2 is 3. So x. Oh, maybe we don't say. So we just say log base 9 of 3 is 1/2. Okay, so we found the value of it as 1/2 because the square root of 9 is 3. Just yes?
Yeah.
Lovely, jubbly. Let's try and get through this bad boy as well. All right, you get given these. Okay, they are written like this. As I said, some of you, these will be familiar to you, some not so much. If we have log statements, and if we notice our base for each of these is the same, so if our bases are the same, and we have 2 separate log statements added together, we can actually combine those to just give one single log statement. And we would do that by multiplying the 2 values. Okay? So for example, if I had log, and I'm not going to write a base so I know it's 10, if I had log 5 plus log 4, what would I say that was equal to? Log 20. Cinchi, yes?
Yeah.
Because I multiply my A and my B.
Yeah, but
understand?
Yeah.
Similarly, if I had a log statement subtract another log statement, I could combine them by dividing my values. Let's leave one in the middle here. So if I had log 12 subtract log 3, that would be log of 12 over 3, which is log 4. Now, I never know when it's a good time to say it because I don't want to confuse people. But this situation here is very different to log 12 divided by log 3. Okay? It's not, you're not dividing everything. You haven't got two log statements dividing. You're just doing 12 over 3. Okay? So just be very aware of that. This one here is one that often people forget. If you have a log statement with something with a power, so for example, if I had log of 3 to the power 4, I could rewrite that as 4 log 3. So my power just literally comes to be in the front. And obviously these are all in reverse as well. So if I had 4 log 3, I could change that to be log of 3 to the power 4. Okay? That's the most common one. But sometimes we do have to split these. Alright, these you don't get told, but it's very good to try and remember them. If you have log of a value base and it's of the same value, that really didn't come out very well. So for example, if I had log 2 of 2, that would be equivalent to 1. The reason being is because if I were to change this to an exponential statement, I would be writing 2 to the power what gives me 2, and that value is always going to be 1. Okay? So this is very, very good to learn. And similarly, if you've got log of any base, and this value here is 1, then it will always be equal to 0. Again, because if you change it to an exponential statement, anything to the power 0 gives you 1. Okay? So they are two things that I would suggest that you had in your mind always when you're doing any kind of log expression. Alright, so we'll do the rest of it next. Yeah.